All right, my friends, let's see how it went. There's more than one way to do the integral there that you see for warm-up 1. But by the end of this lesson, you should have maybe 2 or 3 ways to do this integral if you choose. Neither is better than the other, but we're leading into a method where you can do integrals that are kind of beyond the difficulty level that you see here. Anyway, so before I move on, I do want to point out that for warm-up 1, the integral that you have does have a square root of the form a squared minus u squared. Your a value to get that 16 would be 4, and your u, your function of x that would be in the spot for u would be just x. So hopefully that makes sense. Anyway, so getting started, the method that I've demonstrated in the past, and it's still kind of my go-to, even if I do learn new ways for one like this, would be to factor, kind of get that 1 right there instead of a 16 by factoring it out. And then the 16 can be factored out of the square root as a 4, and then that could get factored out in front of the whole thing as a 1/4. And then the radicand could be written as 1 minus the quantity x over 4 squared. And then from there, you could maybe use a u substitution where if I let u equal x over 4, which is the same as 1/4 x, then my du would be 1/4 dx. And that's super adorable because I have a 1/4 dx just kind of sitting there waiting to be subbed out for a du. And so this would be thought of as the integral of 1 over the square root of 1 minus u squared du. And the thing that's super cute about that is that looks exactly like kind of the opposite of the derivative rule that we've learned in the past. And so this would equal the arc sine of u, which was just a space holder for x over 4, and then plus c. And there, you know, in section 7.1, you would have seen the textbook do that quicker, but it's just a matter of how much memorization, you know, do you want. So the quicker method would have more memorization that you'd have to keep track of. So there you go. As long as you can get that answer, we'll say you got something that works. How about that? All right, let's see. For warm-up number 2, let's look at this guy. So in the radicand there, you have a common factor of 16. And then you could factor the 16 out as a 4, and when we're at it, let's just factor it all the way out in front of the integral. Oops, not x for this. Sorry, guys, d theta. Oof. Otherwise, that makes no sense. Okay, anyway, and then what are you going to do about this? Well, 1 minus sine squared is cosine squared. So do a little Pythagorean swap there. Square root cosine squared. And you've got the integral of cosine. And then you just think, well, what would you take the derivative of to get the cosine? And the answer is sine. And then plus c. And we got it. There we go. All right, my friends, hopefully that makes a little bit of sense. So now let's talk about kind of what warm-up 1 and warm-up 2 had to do with each other. Anyway, so for example 1, they're gonna be 3 tips, 1 for each type of integral. And then we'll show, you know, what you could do with each of the tips. I do want you to just be prepared. Most people really hate this at first. It usually takes maybe until we get to example 2 before people start really feeling good about it. Anyway, you will get the hang of it just like everybody else. You might go through a little bit of you might have some feelings though before you get good at it. I just need you to know that. Okay. All right, so put on your big kid pants and let's go. All right, example 1. We're going to do part A together so you can kind of see how it goes, and then I'll leave you to see what you can do with part B, okay? So the tip that would go along with this example is for integrals involving the square root of a squared minus u squared, and then keep in mind a is a constant and u is a function of x. The substitution, if you're going to use trig substitution, the substitution that would make sense is you would let u equal your a value times the sine of theta. Okay. And then part A is exactly the first warm-up that we had. And you're not going to like this new method better than the method we already demonstrated. You're not going to like it better. But you'll at least see you get the same answer. And then for part B, you would need the new method in order to do it. So, all right. So for part A, let's think about, okay, well, what's your U value and what's your A value? So A is whatever you're squaring to get 16. So A is 4. And U is whatever function of X is getting squared there. And so U would just be X. Okay, so maybe I'll just make a note. Your A value is 4 and your U value is X for this problem. So the substitution that if you're doing it this way, which is a little dorky because we're about to make this harder than it should be. But anyway, your U value, so you would basically let U equal, according to this tip, you would let U equal 4 times sine of theta. Oh man. And then what would your du be? It would be 4 times cosine theta d theta. Good times. Okay. Now, oops, you know what's super funny is I'm kind of messing this up. I apologize. U is X. There we go. Okay. So instead of U, I should have written X. And here's why, because we're about to take this integral right here that's in terms of X, and we're going to write it in terms of theta. So what would that look like? It would look like the integral of 1 over 16 minus, and then what would X squared be in terms of theta? So if you just square both sides of this expression, X squared would equal 16 times sine squared theta. And then according to this, what can I swap out for the dx at the end? I could swap out 4 times cosine theta d theta. And this is a moment if you have got some bad habits of forgetting dx when you write your integrals, it's time to clean it up a little bit. All right, my friends. Now you might see what the second warm-up was all about. It was about really just kind of like having some practice with simplifying radicals like what you see here in our integral. So I hope it makes sense. I'm going to skip a couple steps. You could factor the 16 out as a 4, and then you'd have 1 minus sine squared, which is cosine squared, and then you square root it. Long story short, that whole denominator ends up equaling 4 times cosine theta. And then we're multiplying this by 4 cosine theta, d theta. And come on, that's super cute. The cosines cancel, the 4's cancel. And you end up with the integral of 1 with respect to theta. Oh my goodness. So what is the integral of 1 with respect to theta? Well, it'd be theta plus c. Which seems a little funny, right? Because this integral that you had right here was exactly the same as the integral that you had in warm-up number 1. So why are the answers so different? In warm-up 1, we got arc sine of x over 4 plus c. In example 1, we got theta plus c. Well, we did a substitution in the first place, and so just like back in U substitution days, we would need to go back up to your primary relationship and put your answer back in terms of x. So what I'm going to do is take x equals 4 times sine theta. I'm just going to solve for theta. So I would divide both sides by 4. And then solve for theta by taking arc sine of both sides. Boom. And then take that and sub it in for theta here. There we go. And that is how to make an integral unnecessarily hard. There you go. But at least you can see kind of how this method of trig substitution will work kind of in general. You're going to follow the rule for the correct substitution, write your integral in terms of theta, do the integration in terms of theta, and then go back up to your primary relationship and write your final answer in terms of x. And sometimes it's, tricky, and sometimes it's not. And sometimes it's necessary, and sometimes it's not. So for part A, that was not necessary. We had another method to do it. But for part B, I think you'll find that it's necessary. So between now and the next video, do what you can with part B, poke it with a stick, maybe take about 3 to 5 minutes on it, and then check in with me in the next video, and I can help you with any parts that you get stuck on or make you feel really good about yourself because you totally nailed it on the first one. Good luck.